Hello, Period G. Welcome to this week's edition of Sports Science. Today, we're going to be looking at different NFL plays from a physics perspective.
Football is often considered a game for jocks and for meatheads, but this further investigation will demonstrate the physics behind one of America's most popular games.
Let's embark on our exploration of these different physics principles.
So we have Reggie Bush gets... Oh! No, he didn't. Jack, did you see that?
Why, unfortunately I did. This play illustrates Newton's third law of motion that states for every force there is a force of an equal magnitude in the opposite direction. This means that Reggie Bush is actually imposing a force on Sean Brown that is equal to the force Sean Brown is hitting Mr. Bush with.
Why, that's frankly incomprehensible. Let's take a look at this next clip.
In this display of brute force, we see Jerome the Bus Bettis make the defenders pay as he fights his way to the end zone.
Indeed. This highlight portrays Newton's first law of motion, the law of inertia. This law says that an object in motion wants to stay in motion, while an object at rest wants to stay at rest. The bus contains enough speed combined with his mass to maintain his motion and score a touchdown.
And if there's one thing this bus was doing, it was staying in motion.
I'll tell you what, Jack, that's one big boy. I'm grateful I wasn't on that defense.
Now let's check out another running back who isn't as successful.
Not so smooth.
Not at all, my colleague. Professional football players wear the newest Nike cleats, not just for football swagger, but for a competitive advantage. Cleats maximize the friction between the athlete and the playing surface.
However, in this clip, despite wearing cleats, when the athlete makes his cut, the coefficient of static friction is not great enough, resulting in the athlete slipping and falling.
Now let's talk about the smoothest players on the field, the wide receivers. The wide receivers in the NFL have very soft hands. This has a strong relation to the principle of momentum. By having soft hands, the wide receivers are increasing the time of contact, or the time of deceleration. Having a longer time to decelerate, the force required to stop the ball and make the catch is less.
For our final physics principle, we will be doing an on-field demonstration here at the Sports Science Studios. My colleague Peter is already down at the field warming up. Let's go meet up with him.
Here we are at the Proving Ground at Sports Science Studios. Here we are with our broadcaster, Peter Picerelli. So let's break this down play by play. As you can see, the ball is at rest, which means that all the forces acting on the ball are balanced. Peter here is going to apply a net force to the ball, resulting in an acceleration, conveying Newton's second law of motion. Go.
And all the people should be raising their glasses. Flow crazy, celebrate madness. I never thought I would deliver no classics. Then I hooked up with them and they delivered no classes. I've been keeping it true. Hotel good, long as I can be from the view. Like, damn, how high are we? You gotta gamble in this life, y'all.
Easy, breezy, beautiful, cover girl.
Thank you for joining us on this week's edition of Sports Science, and I hope to see you next time. Which probably isn't a next time, but okay.